My dear Algebra 2 students, today we are going to solve formulas, and they may or may not even have any numbers in them. So I'm going to show you what that means in just a second. Write this down. A formula is a rule for doing a specific calculation. Formulas are often given as equations, and we can solve the formula for a specific variable, whichever one we want to, following the same steps we already know that we already use when we solve an equation. So here's some famous formulas I put up here just for fun. The circumference of a circle is pi times the diameter, or 2 pi times the radius. The area of a triangle is 1/2 the base times the height. And this is a very scary looking geometry formula. And I just put that in there for fun, maybe to freak a couple of you out. Anyway, you don't have to know these formulas. I just put them in there to show you what we were going to be dealing with. So I tried to work some out for you. This is going to be what we're going to be doing in class, by writing the problem in one color and showing you what I'm doing in red. So for instance, if we have this area of a triangle formula and you're asked to solve for what's the base, well, I'm going to write the formula right here, and I need to get rid of my fraction. So I'm going to multiply both sides by 2. That will get rid, I probably should have shown you this, that will get rid of my fraction. And so now I have 2a equals b times h. And I want to solve for b. So the second thing I want to do is divide by h on both sides so I can get the b all by itself. So the base is equal to 2a divided by h. That one was good. We actually had one number in there. All right, here's another example. This one's in my favorite blue color. I tried to show you what I did in red. This equation is P equals 3/5 times C plus 10, and you're asked to solve for C. So the first thing I noticed after I wrote the equation was that I've got a fraction over here multiplied by C plus 10. So I can get rid of that fraction by multiplying by its inverse. And I guess I should have shown you that too, that cancels out, right? Becomes 1, but I have to multiply the p on the other side by the same thing to keep everything all nice and fair and equal. So I end up with 5/3 p equals c plus 10, and I need to get c by itself, so I subtracted 10 from both sides. So now I've got 5/3 p take away 10 equals c. So there's my c all by itself. And all we're doing right now is just practicing these because you're going to practice them in class. And I'm showing you how to work some of them out. All right, let's see. We've got h equals 2r plus 3m. And you're asked to solve for whatever this m is. Well, first thing I notice is the 2r is over here with it, so I want to get rid of it. So I take 2r away from both sides. So now I have h take away 2r equals 3m. And I notice the 3 is with the m, and it's multiplied, so I can divide it by 3 both sides. And when I do that, I'm left with m by itself, and it is equal to h minus 2r divided by 3. All right, my next one I wrote in blue. It is q equals 3r plus 5p, and you're asked to solve for p. So I notice that 3r is added to the 5p, so I can take it away from both sides to get it on the other side of the equation. So now I have q minus 3r equals 5p. And I notice that there's a 5 multiplied with the p, so I can divide both sides by 5 to get p by itself. And so now my p is equal to q minus 3r divided by 5. And I lied to you earlier. There are some numbers in here. A few numbers. Oh, this one doesn't have any numbers. Okay, so So yeah. Here we go. A equals P plus PRT. And you're asked to solve for P. And the first thing I noticed when I wrote this, I just wrote it again right here, was that both of these have a P. I could factor out a P. So I did that, and I tried to show it to you in red that I factored out a P. When I did that, I had a 1 plus RT left. And to get P by its side, since these are multiplied together, I can divide both sides by 1 plus RT. So now my P is by itself. So P is equal to A divided by 1 plus RT. That one looks crazy, doesn't it? But really, we just apply the principles we already know. So don't let all these silly little letters scare you. All right, another one. T equals Q plus QIY, and we're asked to solve for Q. Again, when I wrote it, I noticed that both parts of the equation over here on this side have a Q in common, so I factored it out. I'm left with 1 plus IY. And since it's multiplied by Q, I can divide both sides by 1 plus IY to get Q by itself. So Q is actually equal to T divided by 1 plus IY. All right, last one. Practice for your video is, ooh, we've got an exponent here. X equals, and there's nothing scary about that. I just said that. X equals G, take away G, R squared P. And you're asked to solve for G. Well, once again, I notice that both of these have G in common. So I can factor out a G, which I did right here. Tried to show it to you in red. I'm left with 1 minus R squared P. And since these are multiplied together, I can divide by this to get rid of that. It becomes 1 if I divide by that. So I divided both sides, make everything fair and even. So G is actually equal to X divided by 1 minus R squared P. Yep, we're going to do some of these tomorrow. So I will talk to you then. Goodbye.